All right, all right, all right. This is our beginning of the week weekly review of what we're looking at in geometry this week. A lot of you guys are ACT Aspire testing Tuesday and Wednesday. So I usually record this on Tuesday or late Monday, and I didn't want to wait until Thursday since you guys aren't going to be in class on Tuesday. So I just went ahead and recorded it without you, but I'll have it posted for you to watch when you're ready. We are starting Unit 9, Module 9 here, looking at circles. This is our last unit. End of the year. Let's keep up, guys. If you're behind, get caught up in it quickly here because we don't have much time. The first, let's see, we have lesson 1, lesson 2, and the quiz due all this week. So the first lesson does a lot of vocabulary, as you'd expect, because we have to know vocabulary for what we're looking at with the circle. So on my paper here, I have several circles, and I just want to go over some of the items that are going to be given as vocabulary. And some of these you already know. Like if we have this circle here, and I take a line and I connect the point on this side of the circle with the point on this side of the circle going through the center, you know that that is a diameter, right? That's a diameter. And if I have a point on the circle and I just go to the center but not to the other side, you know that's a radius. All right, so those you already know. You know a diameter and a radius of the circle. Other things you may not know is, for example, you might know this, but like from this point to that point right there, let me just label those. Let's say this is point A, and this is point B, and we'll go ahead and put point C since I'm putting points here. This is arc. Oh. And that's actually arc AB.
Okay, I'm going to let you get off.
Right, because it goes between A and B. You might see it written as arc AB instead of line AB. It's got an arc over the top of it, but that would be that section of the circle that goes from A to B. And when they talk about this arc, they usually talk about it with different terminology like minor arc. A minor arc means it's less than half of the circle. If we were talking about the other, there's another arc AB here. This could be also arc AB. But that is a major arc, right? It's more than half the circle. It still goes from A to B. It's still arc AB. But you would talk about that as arc AB that goes through C. A lot of times I talk about arc AB that goes through C or arc AB that does not go through C. See, they might talk about it like that, or they say minor or major arc. So two ways to name that, but there are two arcs for A and B. So it could be talking about either one of them. The other things we talk about in this is, let's see, concentric circles. If we took this circle and put it inside here and gave it the exact same center where it was inside there, they would be concentric circles. Concentric circles have the same center, right? But different size circles. And all circles are similar, right? So we could dilate any circle to get any other circle using, the radius of this circle would be, we call it R2. We might call this one R1. And so if we were dilating this one to this one, we would just put one radius over the top of the other one, and that would be the scale factor. If we were going the other way around, we'd put this one on top. We'd use that as the scale factor. But if we were going from this one to this one, we would just put one over the other as the radius over the other radius, and that would give us the scale factor that we would need to use to dilate this circle to make it that circle. So we can do that. Other things we look at in here is, let me give you this. I'm going to go from A to C. This is a line that goes from one point on a circle to another point on the circle, but not through the diameter, not through the center. So it's not a diameter. It doesn't go through the center. This we would call a chord. It's a chord. It's a line that goes from one point on a circle to another, but not through the center. The diameter is technically a chord, but we call it the diameter because it's a special chord, right? It goes specifically through the center of the circle where all other chords do not, right? So that is a chord. And from that, we can look at a lot of things because right now we've created several angles right here, right? We've created this angle and we've created this angle. So let me kind of color code those. And there's a relationship between those angles that we will see in these lessons. There's a relationship for sure. So if, let's say that this angle right here, let's say the yellow angle is 80 degrees. 80 degrees. If that's 80 degrees, that means that arc AB is also 80 degrees. All the way around would be 360 degrees, right? A circle's 360 degrees. But let's say that is 80 degrees. So that means the angle formed from the center to those same 2 points that create that arc will be the same angle. 80-degree angle, 80 degrees of the circle. What about our orange angle over here? This point C goes to the same 2 points, A and B, but it's going to be half. It's going to be a 40-degree angle. That's the special relationship you have there. If this goes to 2 points that make an arc, it's going to be half of whatever the measurement of that arc is, the arc being 80 degrees. So since that's 80 degrees, this is 40 degrees. But from the center to that arc will be exactly the same, 80 degrees. So there's a relationship there that's important to know, and you will see questions about that. Let's see, what other kind of lines could we have? You could have a point out here outside the circle, and you could have a line. Let's put a point on the circle. If we had a line that went like that, that touches the circle in only 1 point. 1 point touches it right there. It does not enter the circle, just touches it. This is called a tangent line. Now, we've heard that word before, all right? We've had a whole unit on trigonometry. It uses that same word, tangent. That's a tangent line. And while we're using those words, we could also have a line that goes through the circle. It just cuts through the circle. It creates a chord from there to there. But the line that cuts through there is called a secant line. It's also from our trigonometry module that we had. So we have a secant line, we have a tangent line. And so we'll be looking at those some in these lessons. Okay. So you want to go through that. Let's see, concentric circles. A circumference, of course, we know is the distance around the circle. Okay. Right? We looked at area in our last unit, but circumference would be the same as, like, if it was a rectangle, we'd call it the perimeter. It's really the same thing. It's how far is it around the outside, which for a circle, it's 360 degrees. 360 degrees. And depending on the radius, you could put that as in a radians, right? Because it's 2 pi radians out there. But a radius is going to change the actual number on that. So circumference is diameter times pi, right? Diameter times pi. So you'd need the diameter times pi to figure out in radians how far it is around the circle. But 360 degrees is the circumference in degrees around the circle. So what else will we have in here? Talks about, as I already talked about with this angle, if this angle is 80, then that's angle is 80. If we put a point over here, we know that this CB or BC, whichever arc you would call that, is going to be 180 degrees, right? Because this is a diameter. So that's half the circle, 180 degrees. So from this information we have, we know how big AC is. How big is arc AC? Arc AC must be 100 degrees, right? Because this is 80. It's 180 for the whole thing. So this must be 100-degree arc, which means angle AC would also be 100 degrees. So that's pretty cool there. Here's one that you will see that is a little different, not quite as instinctive as some of the other parts of this circle. If we have 2 secant lines, let's draw 2 secant lines. Right, secant lines, right? They just cut through the circle somewhere, not through the center necessarily, just secant lines that cut through here. If the measure, let me put these arcs on here. All right, so we have that arc, and we have this arc.
Okay. Do I need to talk to you about this?
Let's say that the measurement of this arc is 80 degrees. and that this one is 60 degrees.
Okay, well, it's
Okay.
a date then.
How big is this angle? It's like,
Okay.
oh,
Good
wow.
answer.
Well, that
All
doesn't
right.
use any of this rule because this rule talks about going from the center to 2 points, and this is not the center. Or from another point on the circle to 2 points to make the arc. This is not from a point on the circle.
Okay.
So this doesn't follow any of those rules. To find out what this angle equals, now here's the other thing. Remember, we had vertical angles. They were across from each other. These angles are going to be the same. Whatever this angle is, this angle is going to be, right? Because that's two straight lines. They make vertical angles, right? So what is either one of these angles? To find that, we take these two arcs that are created outside here and we add them together. 80 plus 60, which is 140. And then we divide that by 2. Divided by 2 is 70. So these are both 70-degree angles. Basically, we just take the average between those two. We add them together and divide by 2. So this is 80 and this is 60. Then the angles created inside the circle are 70-degree angles. So something to play with that. Oh, I about had that off your screen, didn't I? 80 and 60. Those are going to be 70-degree angles right there. So you're taking the average primarily between those two. So that is a lot of what's going to be in lesson 1. Lesson 2 does a lot of this, figuring out angles based on arcs and all of that, at least the assignment part of that. The lesson's got a lot of stuff in there. One thing that's in the lesson that's not going to be in the assignment, but it will be on the quiz, is we get back into some constructions. Because when you talk about constructions, circles are primary, right? Because we do a lot of circles with our compass. So there is some constructions in here. It talks about a perpendicular bisector, and there are questions on the quiz about the steps for a perpendicular bisector. Now, the nice thing is in the lesson 2, there are videos that review all of that and show you all of that stuff again. So be sure to watch the videos. You know, if you go in there and spend 6 or 7 minutes on the whole lesson, I know you haven't watched the videos because the videos, there's multiple videos in there that are each a couple of minutes long, and you're not taking the time you need to, which is going to hurt you when you get to the quiz and the exams. And this is our last module, so we got the finals coming after this. So this is a great time to go back and review some constructions because you never know what you're going to see in the final, right? It covers the entire semester, and we spend quite a bit of time on constructions back earlier in the semester. So be sure to go through those lessons 1 and 2 and look at those things. For the quiz, let me look at the quiz real quick to tell you what kind of questions you're going to see on the quiz this week. So on the quiz, you will see a couple of questions, again, about constructions, and they're talking about a circle inscribed in a triangle, right? Because we're going to make a circle inside a triangle, part of construction this time, because this is about circles. And with triangles and circles, there's a lot of cool stuff we could do. So there are some videos that show you that. So you need to pay attention. You might even pull out your compass, dust it off, because we did that way back, gosh, that was the beginning of the year that we did constructions. What is back in September we did it. It wasn't even this semester. You want to go back and pull that compass out and do some of that with the video. Boy, that would really help you. You would understand a lot better. So you'll have a couple of questions about a circle, circumscribed by a triangle, or inscribed in a triangle. It's two different things. You can have the circle inside the triangle or the triangle inside the circle, either way. So there are 2 different questions on the quiz. There's also a question about, let me show you this. I already put this together a little earlier. You could have a quadrilateral, just a 4-sided shape that is inscribed in a circle, right? Inscribed means the 4 vertices of the shape are on the circle. So in this case, the thing to know, and you'll see this in your lesson, be sure and go through this, is that the opposite sides are going to add up to 180 degrees. The opposite sides add up to 360 degrees in a 4-sided shape, but 180 here and 180 here. So if it gave you this, and this was blank, it would say, how big is this angle? You'd have to first figure out x. So 8x plus this x, add those 2 angles together, they should be 180 degrees. So you can go 8x plus the x equals 180, because those 2 should do that. So it means over here you got 9x equals 180. Divide both sides by 9. You know x equals 20.
So be sure to
So if
watch
this is 5x, that means this must be 100 degrees.
to take that test.
If that's 100 degrees, then this must be 80 because they have to add up to 180 in a inscribed quadrilateral in a circle. So there's a question like that where you're going to have to figure out the measure of one of those angles, and they'll just give you information like this, where they'll just give you like an 8x and an x or whatever they give you. And you'll have to know that adding those together is 180. What is x? So a couple of steps involved, but you can do that. And then the other question on the quiz will be back to using our angles like this.
Okay.
Say if we have a point, and let's say we've got another point over here that we connect to those. And taking a kite, we'll put a kite inside of a circle, right? Put a kite inside your circle, and then it'll say, okay, for this circle, it'll say that this arc here
Okay, so
is, let's say it's 250 degrees. All right, just made that up.
3.06 even.
If that's 250
Mass
degrees,
and weight.
if that is 250 degrees, what is this angle? Oh, how are you going to do that?
Mass and weight. So
That
mass
is 250 degrees. What is this angle?
Good morning, Timothy. Mass
Well, this angle would be half of what this is, right? What this arc here, because it connects from there to there. That's the 2 points. That is the point that it goes to right there and right there. So the arc between there, this would be half of whatever that is. Well, you should be able to figure out what that is, right? Because if this is 250 and the circle is 360, that should tell you exactly what that is. Take half of that. There's your angle. So there will be ways to use kites to your advantage to get that information. 250 degrees, we know that this angle here must be 125 degree angle. 125 degree angle because it connects to the 2 points that make that arc, and it should be half. That's 125. That's another way to figure out what this one is, right? Because this is a four-sided figure. So these have to equal 180. Are you starting to see why they have to equal 180 now? If all the way around is 360 and this angle both connect to make all 360, that means together they would have to be half of the whole thing, 180 degrees. So, all right, that is really the overview of the 2 lessons in the quiz that are this week. This is our last module. We're going to get through this module and then have some time to do a little practice problems and review before finals, because finals is going to be here before you know it. We are halfway through April already. This week is halfway through April. So wow, we're going to be done with April and into May very quickly. So if you are not current on assignments, don't delay. This is the time to do it. You need to be turning in something every day, not just class days, Monday through Friday. And if you're way behind, you might need to go Monday through Sunday for a while to get caught up. Because look at how many, everything's posted now. Look at how many things are left and see how many assignments you have. Count how many days are left, how many assignments you have, and you see you may need to do one a day or more if you're way behind. So don't keep lagging behind. You can do this. If you wait till the middle of May, you might be in trouble and can't pull this out. But you don't want to take geometry again next year. Get this done. Get caught up if you're behind. So, all right, do work you can be proud of, and we will see you next time.